Welcome to Study with the Best, the magazine show that's all about CUNY. I'm Tinabeth Pina. On today's show, we've got technology stories across the CUNY spectrum. We have advances in 3D animation, smart gun technology, artificial intelligence, and so much more. First up, so how is the technology behind video games changing the science of animation? Lisa Beth Kovitz walks us through this process with two CUNY tech experts.
Animation has leapt out of the pages of our childhood and filled our screens with amazing images. When we watch animation in a movie or on TV, the images all have the appearance of being in 3 dimensions, but in fact, they're not. All these images are actually flat, 2-dimensional drawings with really cool shading. But in virtual reality, augmented reality, and video games, the action takes place in 360 degrees, and so the animation must be created in 3 dimensions. So, how do they animate in video games? Talal Choudhury of Smack Marketing has agreed to show us the tech behind a video game he created just for fun. And, just for fun, I invited Vinod Menon, a CUNY professor specializing in light, along for the ride. In a video game, a player might, at any moment, rotate his point of view to a new angle, and therefore, every object must be visible in 3 dimensions all the time, and so every object, animated or still, starts out as a 3-dimensional model. The model is given an internal skeleton, and then, by manipulating the skeleton, the character moves. It's a long, detailed process, and it all starts with the model.
3D modeling is more of an art form, I think. People can make crude models really quickly, but the challenge is, hey, how do you make those models look realistic?
There are lots of prefabricated models all over the internet, but to acquire interesting new models, Choudhury has combined emerging 3D tech in a unique and interesting way.
As soon as I found out about 3D scanning, as soon as I found out that, hey, you can scan people, it's like, hey, I could do a lot with this. As soon as I got my hands on one of these scanners, I immediately started scanning all my family and friends and coworkers.
The scanner Choudhury is using is one of several new pieces of technology that capture images in 3 dimensions.
As a physicist working in lasers, what do you think is happening there optically?
So I think the 3D scanner actually has 2 cameras. One is the camera on the iPad itself. The other is the camera that it has on the structure sensor, which is an infrared camera. So in addition to the infrared camera, it also has a structured light projector, which is probably an infrared laser or an infrared LED, which projects a grid onto the free space. And any distortions in this grid is what is recorded by the infrared camera, which then translates that to depth information. Combining this depth information with the visible camera's data, you get the entire 3D picture.
Talal used this technology to scan friends and coworkers to be used in a special experimental project.
This project is called Smackdown.
In Smackdown, Choudhury rigged his friends' scans with digital skeletons and then gave these new characters some basic computer-coded fighting moves. So let's break down how he did that.
If I can scan someone in a A pose or a T pose, I can use a lot of software and tools and algorithms to automatically rig their skeleton. And then once I have that, I can use that in a game engine like Unity and just play with these characters.
I asked Choudhury if he would put us in the video game, and he said, no problem. It only took a couple of minutes for him to scan Professor Menon and me in standard A poses. Then, he rigged our skeletons by indicating the location of a few specific joints. Once the skeleton was in place, the models could be animated at will.
We're entering a really, really interesting world.
But what if you're not into video games? Is this 3D animation technology going to spill out into the rest of the media landscape?
Is 3D animation the marketing of the future?
I think so. The web e-com experience is going to keep changing. If we can make that experience any better, like, hey, why not? We have to challenge ourselves to, make the web, the internet, a better place.
How have mobile devices affected the grieving process? A College of Staten Island author and teacher explains.
We use this term mobile emotive to represent this idea that now mobile phones are becoming a part of our emotional lives. Some mundane text message that we might receive from a loved one, like a grocery list or don't forget to pick up a present on the way home, suddenly takes significance once that person is gone. The resistance to delete photos, the resistance to delete last messages, keeping a person in your contacts, in your phone book, allowing there to be a sort of cycling of photos, that would appear on your screen, and also the active social media pages that could be readily accessed through your mobile device, creates this sense of extended haunting coming through your phone of loved ones left behind. For my piece of the book, I conducted 42 interviews with New Yorkers. The call for subjects were really simple. Yes, I own a smartphone, and yes, I've experienced some form of loss. People started speaking about how they feel as though their loved ones are still in communication with them via their devices. Not unlike the experiences in the 1800s, early 1900s of people believing that you can communicate with the dead through also the invention of electricity, comes this idea that this new technology may breed new forms of spiritualism, where people can actually believe that a person, one, that they can have literal and sometimes symbolic communication with the dead, and also that there's a sense of immortality for all of us in the digital traces that we leave behind on our phones. We even have an instance where a young person felt like they were still in text message communication with their best friend who had died in a car accident, and that she would anticipate what her responses would be, but she still felt like there was a presence in the phone of her best friend. And a young woman who lost her mother, who also felt as though she could replay videos that she had recorded on her devices, and in the right intimate physical space could feel as though she was conjuring the presence of her mother through those videos. The storage capacity of the phone, the way that it can hold mementos in our phone like a treasured memory box, was something that we really wanted to explore, and emerged as people were talking about the role that phones were playing in their grief and loss experience. We would have these stories of how people would cradle their devices as though it was their loved ones. People started speaking about how they feel as though their loved ones are still in communication with them via their devices beyond death. In our conclusion of our book, we really try to expand the work to really focus on some of the more recent things that have happened, like police killings that have been broadcast through body cams, mobile phone video footage, and how that shapes and changes our perceptions of death, and that we can literally bear witness to mass murder, as it's happening. There is something very compelling to me about wanting to do this work. I actually get a lot of joy out of highlighting how people can be resilient, quite resilient in real desperate moments of their life experience. I developed an upper-level psych course on our campus, and also a seminar that has run at the Graduate Center on the social psychology of mobile technology and social media. I try to get my students to have a certain ethical view on how we engage with technology and use the technology. We really need to preserve the more academic side of technology, because people in industry have a different focus, and that we need critical thinkers, academics and scientists who are looking at the social, cultural, and political consequences of the use of information. The work that we do in the classroom is geared towards how to take a critical perspective as to engaging in new technologies or how we use our technologies, as well as trying to form a sense of ethics around the use of technology, especially as it relates to physical health and social and political consequences.
Artificial intelligence is always making headlines, but the AI of science fiction is very different than reality. Ari Goldberg sat down with Hunter College's Susan Epstein to find out more.
There was a time period where artificial intelligence made the cover of Time magazine, and those expert systems were going to take over everybody's jobs and the world. And none of that came to pass because there's a level beyond which science becomes hype.
In the movies, AI is the stuff of killer robots and mad scientists. But what exactly is AI in present-day real life? Where's the line between just a computer and artificial intelligence? Susan Epstein is a professor of computer science and machine learning at Hunter College.
Artificial intelligence is the simulation of intelligent human behavior. And human behavior because if there were something smarter, we'd probably study that instead. If you're trying to build an intelligence, one of the nice things you can do is think about it like building a baby. And if you do that, then you put this child in a very rich environment and then sit back and watch and see what it figures out. You could also teach it, but that's slower and probably you don't teach it all the right things.
The key word here is simulate. When we think of artificial intelligence, we often think of emulating humans, the science fiction dream of machines that think and act, and often even look, human. But the core of AI is simulating the human phenomena of the learning, understanding, and application of knowledge. And that can take many forms.
Artificial intelligence would like to solve really hard problems harder than problems that people can solve. In the meantime, if it solves problems that we respect the solution of because we think the problem was difficult to begin with, we'll call that an artificially intelligent machine.
What can artificial intelligence be applied to?
Good example. This year, as a matter of fact, dermatologists went head-to-head with a computer vision system to see if they could look at photographs and detect what kind of skin cancer or any skin cancer they were looking at. And the machine did just as well as the dermatologists, equally as well statistically.
Obviously, this isn't an android doctor walking around visiting patients, but it is solving a complex problem, so it is artificial intelligence. But even just something like Apple's Siri or Amazon's Alexa qualify.
These machines are considered a form of artificial intelligence only because they are doing what we call natural language processing, as opposed to a programming language. So we are communicating with the machine using our natural language, and they are responding in kind. And that is an achievement.
When we have computers diagnosing cancer, a voice in your phone may seem underwhelming. Scientists call that the AI effect, where once an AI application is mainstream, people no longer think of it as solving a difficult problem, and therefore not as intelligent. But the ability for a program to interact back and forth with a human is no small feat.
The essence of communication is having a shared frame of reference. If you want a robot and a human being to communicate with each other, the only way that's going to happen is if the robot sees the world the way the person does. All a computer can process are zeros and ones. Don't forget that.
And that's why free-flowing communication with a robot, like in the movies, is so difficult. How do you translate the vastness of the human experience into ones and zeros that a program can understand? But as computer hardware and processing speeds improve, it's amazing how much we can already simulate.
Embedding a personality in a machine is not hard at all if you've got the right program environment. I can make a game player take risks. I can produce what appears to be a baffled robot navigator simply by telling it that it's not allowed to get within 5 feet of a human being and then putting it in a hallway full of people. It's going to look really dumb. Whether or not a robot has a sense of self, or a computer for that matter has a sense of self, is an interesting question, but until we understand better what an emotion means in a human being, I would be extremely reluctant to say that I can create an emotion in a computer. Tell me about how a person does it first.
In fact, a lot of advanced AI technology now is indeed inspired by how our own brain's neural network works. They're called artificial neural networks. Just like Epstein's analogy of a growing baby, these complex algorithms can even learn how to learn. But that doesn't mean the ominous sentient robots of Hollywood are right around the corner.
Almost any advance in science can be turned one way or another. We're all responsible for what we do with our science, whether it's artificial intelligence or radioactivity or the ability to change a gene or control one. There is a huge movement in the artificial intelligence community that is several years old now to look at ethics with respect to artificial intelligence. There are many really brilliant and well-versed people who take this very, very seriously. I think that societal norms and respect for humanity has to at some point be encoded somehow. It seems to me that the place we should go appropriately at this point is collaborative intelligence. And what my vision would be that a machine and a human would work together as partners to accomplish a goal that was set by the human. So the first thing that does for you is it gets you away from worrying about what this machine is going to do by itself. The second thing it does is it forces the machine to communicate with the human being in ways that are supportive. You can't just take a piece of science and say, that's too dangerous, we're not playing. What you can do is try and play intelligently.
For Study with the Best, I'm Ari Goldberg.
Baruch College students recently took part in a competition that enabled them to use IBM's powerful Watson computer to help find solutions to a myriad of problems. Let's take a look. Cognitive technology, sometimes referred to as artificial intelligence, has transformed industry after industry, from law to medicine, from education to retail. The annual CUNY IBM Watson Case Competition at Baruch College was designed to increase awareness of the new era of computing and allow CUNY students a smooth transition into the competitive job market of the 21st century.
IBM, as most people would think of it, have been historically identified as a computer manufacturer of hardware. But a major part of what they've been doing is really to develop software that is capable of not only doing the normal standard kind of calculations we think of computers doing, but it's also able to kind of understand what people are requesting, that is, what's the question that's being asked, and find ways to improve on the answers it gets.
Watson can read through hundreds of thousands of pages of documents in seconds. So if you're looking for specific information, Watson, in a matter of 2-3 seconds, can have all the relevant information to what you're looking for from a ginormous database of information.
But you don't have to be a scientist to be able to work with artificial intelligence. IBM Watson comes with Bluemix, a set of digital services that makes cognitive technologies accessible to everyone.
To actually use the IBM Watson Bluemix platform, I don't believe you really need a computer science background or mathematics background.
No, you don't.
To be honest,
whatsoever.
The whole Bluemix platform is very user interface friendly.
Watson isn't a search bar. It's not Google. It's not something you type your answer to and get it back. There's tools that can organize and sort information and then feed it back to you.
There are 26 other apps within Bluemix, and so as you're thinking about how to improve the world, the whole idea is to take a supercomputer and several of those APSs and apply them to different problems and try to solve them.
However, Watson still needs a human touch.
Watson doesn't just start out knowing everything. One of the first real steps is that the main users of this system have to train Watson in the context in which they want to use it.
During the competition, as I was doing a lot of research, I realized that not all the facts might be needed to be presented at the same time. You have to be very selective.
Yeah, but essentially, what he was picking up on, with that, doing the video animation, the business case analysis was pretty challenging, and we all had to kind of help each other, regardless of our roles in the group.
And the more you work with Watson, and the more Watson accesses the data, and the more Watson learns about the subject, the more complicated the questions Watson's able to answer.
The fear with this technology is that it's going to take humans' jobs, and that now we're going to become so outdated we're not going to be able to compete with technology. But our team took the approach that this allows humans to focus on things that are essentially human. So We saw Watson as an opportunity to allow humans to be humans and allow the computational robotic stuff to be left to computers.
The goal of last year's competition was to explore ways in which IBM Watson and Bluemix services can be applied to higher education and the delivery of public services by New York City. But the range of possible applications of this technology seems endless.
From my point of view, we have a responsibility to the 250,000 students who go here to prepare them for the 21st century. And one of the characteristics for the 21st century is to be lifelong learners.
This competition, it's mainly about coming up with an innovation, a new idea. So in order to come up with a new idea, you don't need any background in any field. You just need to be innovative.
And I do believe that IBM will be the future, especially for artificial intelligence or maybe artificial consciousness if we're going that far.
For the future of Watson, that we're really, there's a humanized face behind Watson, and there is conversation that can take place between humans and technology, and it can take place on our terms. And that was what we learned in one of the training sessions, that the future of Watson is dynamic and expansive, and we don't know where this is going to end up, but we know it's going to be big.
A smart gun is a gun that recognizes who its owner is, possibly reducing gun violence and suicides. Mariev Ami has more from City Tech.
Last summer, Brooklyn Borough President Eric Adams initiated a smart gun design competition for local colleges and universities in an effort to advance the research of the smart gun technology. Although they did not win, New York City College of Technology students were among the finalists to receive a grant in order to further their work.
We use gun, several hundred years ago. So the design of gun is already matured, but we are challenging the new design, including the smart device.
Can you show us the prototype that you designed and explain how it works?
We customize this smart gun. So we have several features. In order to unlock, we have a gesture combination. So I set up the very simple gesture to unlock. The red one is the trigger. So now, right now, we cannot shoot, but once I put the gesture, I can shoot. In order to show clearly, I put the simple gesture, but the user can assign any combination.
Their design is also meant to reduce the rate of suicide, since the U.S. faces more death by suicide than by homicide, with firearms being the #1 method of suicide.
The smart gun design we have has the proximity sensor, which locks the gun when it's close to your head or body. So that will instantly reduce the suicide rates in the society.
Other function is the GPS for location restriction, and GPS detect the signal from satellite. So for example, this is a campus. So we can set up in this campus, this smart gun cannot use. And also we will have a wireless network connection. So once we fire the smart gun, the signal will be emitted. The main purpose of the signal is just sharing information when the gun is fired and which direction and where.
The data collection could offer the police an additional way to recover criminal evidence, but could also help predict gun users' behaviors and therefore potentially prevent gun violence.
Moving on with the smart gun project, I'm going to help Professor actually manufacture the gun. So we have to see basically which model of gun would work best for implementing the technology, because a gun is a compact device. We have to find space for the features, and then we'll see, is the smart gun going to ultimately replace traditional guns, or is the smart gun going to sort of just fill a niche role like law enforcement, something like that?
Despite the great potential to reduce gun violence, smart guns face controversy.
The data thing smart gun has, it will store your location, and it will have like the GPS sensor. So that's the main reason the people are not like in favor of smart guns, because of the privacy issues. And there are some also technical issues as well.
The greatest challenge the smart gun faces is that it is an electrical device which can malfunction.
Computer processor become much faster. We are finding the new technology or new innovation every year. So I'm very optimistic.
Do you have an idea of how much it would reduce gun violence?
More than half of the current suicide and the current accident can be reduced. More than half.
I think it's the smart gun. It's the natural next step to a gun. I mean, everything's getting smart. Refrigerators are getting smart, toasters are getting smart. It's time for guns to get smart.
While the initial idea of a smart gun has a lot of potential, it remains to be seen if gun users will accept the smart gun technology and constraints that come along with it. For Study with the Best, I'm Maria Vamy.
That's our show for today. For more information on any of our stories, log on to our website at CUNY.TV or check out our Study with the Best Facebook page. Thanks for watching, and I'll see you next time. Bye.